Welcome students and viewers. In this video, we are going to have a lesson on circle theorems. So this is the subject, and we are going to treat circle theorems. Okay, but before going to directly going into circle theorems, students and viewers should recall some things about a circle. That if you have a circle, that a circle is a locus of points, equidistant from a fixed point called the center. So in this video, we shall always denote the center as O, the center of the circle. And there is a radius. You know, a radius from anywhere from the circumference to the center of a circle is the same. So if this is a radius, this is another radius. So all the radii here are the same. From here to here is equal to from here to here. Reason radii. So radius of a circle is throughout a circle the same. And students and viewers should also note that if you have a circle, the straight line which passes through the center, if this is the center of the circle O, if a straight line passes through the center joining two parts on the circumference, then this is what we call a diameter. So this is a radius from here to here. This is another radius from here to here, from the center to this part of the circumference. So now the line AB is a diameter, and as such, OA is equal to OB. The line OA and OB are the same, simply because the two are radii. So now a line which does not pass through the center but joining 2 points on the circumference is called a chord. So a diameter is a spatial chord because it passes through the center. So now AB is now a chord. It divides the circle into two segments. So here is the major segment, and here is the minor segment. But a diameter which divides the circle into two, so this is a semicircle and the other half is a semicircle. So the two segments of this circle are the same. If the line here, the line CD is a diameter. So if the chord is not a diameter, just like AB, then here is the major segment and down here is the minor segment. And here is called the minor arc. And from here to here now, from A down on the circumference, down to B is what we call the minor arc. So let me write fully the minor arc. And here is the major arc from here. From here. I'm taking this now. From here down to here, up to B. This is the major arc. So these are some of the things we may recall before proceeding. Also remember that if you have a triangle, any triangle, ABC, that the sum of angles here, the sum of all angles in a triangle is 180 degrees. So that now this angle, as you see, this angle is A, so we can write it as BAC, meaning BAC. this angle. The letter in the middle is the one sitting on the angle. So that ABC, BAC is this angle plus this angle ABC, that is ABC. Sometimes we put the angle on the middle letter, or sometimes we just write ABC and write the angle here from the beginning. But I would like to adopt this throughout this video. So plus this angle we write it BCA or ACB. It's all the same. So BCA. So this is equal to 180 degrees. So if you have a triangle, meaning this angle from plus this angle plus this angle is 180 degrees. Also, students and viewers should note that if you have an equilateral triangle, sorry, not an equilateral triangle, isosceles triangle, where two sides are equal, if this side is equal to this side, actually this is an isosceles triangle. These two lines are equal, so here is ABC. If it is an isosceles triangle, the line AB, we write something like this, plus the line AC, sorry, the line AB is equal to the line AC. And therefore, as such, you have the angle ABC is equal to the angle BCE, meaning the base angles of isosceles triangle are equal because the two lines here are equal. So let's start now. We start with a theorem, theorem 1. The theorem states that the angle which an arc of a circle subtends at the center twice the angle which it subtend at any part, at any point on the remaining part of the circumference, on the remaining part of the circumference. So what this theorem is saying that if you have a circle is that if you have a circle with center O and you have something like this, so the angle subtended by an arc of a circle at the center, this arc subtend at an arc, an angle here at the center, it will be twice that angle which it subtend at any point on the remaining part of the circumference, any point here. So this is what the theorem is saying. So let me name here A, B, C. So now we want to show that the angle here is twice this angle. So if here is x, then here will be 2x. So to prove now, we are given uh, the circle O A, sorry, the circle ABC. That is the circle we are given with the construction inside, and then we are to construction is that uh, we produce a line, call it a line AD, meaning to pass through the center of the circle, to extend and pass through the center. So what this means is you construct a straight line to pass through the center up to a point D. Okay, so now what to do? We are going to prove that we are given this to prove. What are we going to prove now? What to prove that angle BOC, actually this angle is equal to 2 times angle BAC. BAC, this angle. So this angle as a whole, BOC twice BAC. That is what we are going to prove. So we start with the proof. So the proof goes like this. So now we have produced this line up to D. So you see that we have two triangles. Triangle ABO and the triangle ACO. Okay, so now observe that line OE is equal to line OB, and that is equal to line OC. This line OA is equal to the line OB is equal to the line OC. What is the reason? The reason is that they are radii. This is the plural of radius. So now, since this line is equal to this line, now from this triangle AOB, I mean this triangle here, what do we have? We have this line OB is equal to OA from here. So it means uh, the base angles this is an isosceles triangle. And so the base angles are the same. So that what do you have? From that triangle, you know that angle ABO is equal to angle BAO. This angle ABO, this angle is equals to BAO, this angle. So sorry, not this angle. So that if here is x, here will also be x. Okay, so let that be equal to x. So y, we have to state the reason. Base angles of isosceles triangle. You know, the base angles of isosceles triangle are equal. So that is that. Now also from triangle AOC, from triangle AOC, we have that angle ACO, this angle ACO, this angle here, is equal to angle BAO or CAO. Yeah, that this angle CAO, this angle. So let that be equal to y. So this angle is y. This also must be y. Reason: base angles of isosceles triangle. Base angles of isosceles triangle. That is the reason. So actually, this angle is x. This angle is x. This angle is y, and this angle is y. Is also y. So we see clearly that, therefore, based on what we have here, we see that this angle BOD is equal to this angle BOD is equal to uh, angle, what is that angle? This angle plus this angle. Okay, so that is equals to angle ABO plus angle BAO. So this angle plus this angle is equal to this angle BOD. Why? Exterior angle of a triangle. So exterior angle of a triangle. No, there's a theorem that says the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So that this is equal to 2x. Okay. So now, so here is 2x. So consider this angle again. These two angles. Similarly, the reason is the same. So this angle A on the other triangle we have ACO. So sorry, what I'm trying to say is this angle COD, angle COD is equal to this angle is equal to this angle plus this angle, but that angle is ACO plus CAO, but that is equal to what? 2y. So here is 2y. Same reason. Exterior angle of a triangle. So exterior angle of a triangle. Now the sum of the exterior angle of a triangle twice is equal to the sum of the two opposite interior angles. So this is 2y and there is y, here is y. So here is x, here is x. X plus x becomes 2x. So, but remember that recall, okay, remember that these two angles, angle B, so this angle at large is equal to this, we call it angle BOC, is equal to which angle? This is equal to this angle BOD plus COD. So BOD plus COD. COD. Yeah, when you sum this angle plus this angle, it will give you this large angle. And so, but BOD plus COD, this is equal to what? 2x plus 2y. But what is 2x plus 2y? So that is equal to what? 2 into x plus y. But look at this angle. So now angle, if you look at it, so angle, this angle, which is angle BAC, the one in question, angle BAC is equal to what? X plus y. So therefore, so this angle BOC is equal to 2 times BAC. So therefore, angle BOC is equal to twice angle BAC, meaning that this angle here is 2 times this angle. You multiply this angle by 2 before you get this angle, and that is the proof. Okay, so that proves the theorem, meaning angle at center twice angle at circumference. So this is a very important theorem which shall be used to prove several theorems under it. So next, we have a corollary. Corollary. We have a corollary, the immediate consequence of the theorem we have just proved. So the corollary is, so corollary 2, because that is theorem 1. So corollary will be number 2. And so the corollary is saying angle on a semicircle is a right angle. Semicircle is a right angle. You know what a right angle means? A right angle is an angle that is measured 90 degrees. A right angle meaning up to 90 degrees. You know what a semicircle is? You have a circle and you have a diameter passing through, and any angle that is formed from the end point of the diameter on any part of the circumference is what we refer to as angle on a semicircle. This, even though not drawn to scale, O is the center of the circle. So you have a diameter like this. So you have an angle formed this way from from the end point of the diameter to meet on any part of the circumference, even if it is here or here, then you have a right angle. So this is what they're saying. Then this angle is a right angle. So that is immediate consequence of what we have just proved. We have proved that angle at center twice angle at circumference. So even if you are proving, you know, the proof is angle at center twice angle at circumference. So here is A, B, C. So you know that angle BOC is equal to what? 180 degrees. This angle is 180 degrees. Why? This is angles on a straight line. The sum of angle on a straight line is 180 degrees. Therefore, we conclude that angle BAC is equal to 180 divided by 2, and that is equal to 90 degrees. Why? This angle twice this angle. That is the reason. So the reason is that angle at center, the theorem we have just proved, twice angle at circumference. Angle at center twice angle at circumference. That is the reason. So BAC is equal to 90 degrees. So any angle on a semicircle is angle that the measurement is 90 degrees. So let's take some few examples before we proceed. So we have an example. Example 3, because we are naming the theorems and example correctly. So this one is saying you work out the size, meaning find the size of each angle marked with a letter. So here is one of them. This one is okay. This one is something like this. Okay, here is B. Please not drawn to scale. Here is the center. Okay, here is the center O, and here is A. Here is 92 degrees. Okay, this is A. B, we have a circle like this, and we have something like this. O is the center of the circle. Here is 150 degrees. Here is X. We have a circle C. Here is a triangle. Okay, this is a triangle. Here is the center of the circle. Here is 2C. Here is just C. And here is X. Okay, so let's sorry, not X. Here should be left the way it is. Yeah, that is how the question is. So let's look at solution to example number 3. A. If you look at A, here is 92 degrees and we are looking for letter A. So simply the angle A will be equal to 360 degrees minus 92 degrees. 360 minus 92. So why do we say so? So that if you have 92 plus A, it will give you 360 degrees. That is sum of angles at a point. Sum of angles at a point. That is the reason. So 360 minus 92. So A is equal to 360 minus 92. 360 minus 92 will be 200 and so here will be 300 minus 32. Here will be 268 degrees. So A is 268 degrees. And we are done with question number, we are done with angle number A. Now, what of angle B? Now, angle B will be equal to what? Angle A divided by 2. Why? This is because angle at center twice angle at circumference. That is the reason. So the angle which an arc of a circle subtend at the center, it will be twice that which is subtend at the circumference. So here is 268, then here will be half of 268. Actually, B is equal to 268 divided by 2. And that will be 268 divided by 2, 134 degrees. So we have solved question number A completely in example number 3. Now we are going to question number B. For question number B, we are just solving direct because here is 150 degrees. So angle at center twice angle at circumference. So this center is x and the circumference, the angle at center is 150 and the circumference is x. So meaning x is half of whatever angle that is here. So x is equal to 150 degrees divided by 2. And that is equal to 75 degrees. Why? We have to state the reason. Angle at center twice angle at circumference. So please note that I am using short symbols to avoid maybe filling of the space. I'm trying to save space. So now we are solving question number C. So I have to clean here because I don't want to clean the question while solving. So for question number C, we are using directly a corollary. And the corollary is, if you have, this is a triangle. So let's name, we have to label this A, B, C so that it will be easier for us. This angle, this triangle, you have CA, this angle, CAB, this angle, CAB, this angle plus this angle ABC plus this angle BCE or AC B is equal to 180 degrees. Why? We have to state the reason: sum of angles in a triangle. So whenever you see me writing this symbol, I mean a triangle. This stands for angle. Okay, but this is 2C, this is C. So this angle A is 90 degrees. Angle CAB is equal to 90 degrees. Why? The reason is angle on a semicircle. Angle in a semicircle. Angle in a semicircle is a right angle, and therefore it is 90 degrees. So that this equation becomes 90 degrees plus this angle B is C, plus angle C here is 2C, equal to 180 degrees. Right from the, so that you have C plus 2C, that is 3C, is equal to 180 degrees minus 90 degrees if you collect the like terms. So that 3C is equal to 180 minus 90, and that will be 90 degrees. So that you are dividing through by 3 or dividing both sides by 3, you have C is equal to 90 degrees divided by 3. 90 divided by 3, that will be 30 degrees. So that C is 30 degrees. So here will be 60 degrees, and here will be 30 degrees. So that 60 plus 30 is 90. 90 plus 90, you have 180 degrees, exactly the sum of angles in a triangle. Okay, so now what we are left with is to okay, yet another interesting example before we go to the next theorem. This is example number 4. In example 4, we have in the diagram below, find the value of x. Find the value of x if y is equal to 35 degrees. So here is the diagram. This is the diagram. While O is the center of the circle, here is y, and here is x. We are asked to find the value of x. All right. Solution. To find the value of x, let's name here A, B, C in case of any nomenclature. We are given that y is 35 degrees, and we are looking for x. We are asked to find the value of x. Remember, if you look at this critically, that in this triangle AOB, so from triangle AOB, okay, let me write the triangle symbol AOB. From the triangle AOB, this smaller triangle, what do we have? We have line OA is equals to line OB. What is the reason? These are radii, the plural of radius. Observe that this line OB starts from the center to the circumference, and similarly line OE. So therefore, they are radii. Each of the lines is a radius. So since that is a radius, that implies that this triangle AOB is isosceles triangle. Therefore, y is equal to, this angle y is equals to angle BAO. Angle angle BAO, and that is also 35 degrees because y is 35 degrees. Why? The reason is that these are base angles of isosceles triangle. You know, the base angles of isosceles triangle are equal. Once this line is equal to this line, then AOB becomes an isosceles triangle, and the base angles must be equal because the lines forming those angles or above the two angles are equal. So meaning here is 35 degrees. Here is 35 degrees. Let me just say 35 degrees to save time. So, but remember, this is a triangle, and therefore, angle Y plus that angle BAO, yeah, plus this angle, which is AOB, I mean, not the reflex, AOB, because I'm making reference to this triangle and therefore I'm not going outside. So don't consider the reflex angle there. So this is equal to 180 degrees. Reason is sum of angles in a triangle. Sum of angles in a triangle. So, but what is angle Y? This is 35. We got this to also be 35. So we have 35 degrees plus 35 degrees plus this angle, which is AOB, is equal to 180 degrees. You know, so we have to 35 plus 35, and that is 70 degrees. So you know, AOB is equal to 180 minus the sum of two 35s. And that means AOB is equal to 180 minus 70 degrees. But AOB is then equals to 110 degrees. So this angle is 110 degrees. Remember, we are looking for x. We have gotten this. So therefore, whatever is happening in x, it should be half of this angle. But x is equals to what? This angle AOB over 2. And that is equal to AOB over 2, and that is 110 degrees divided by 2, and that is equal to what? 55 degrees. Why do we make such statement? Is that angles at center, just our main theorem, twice that at circumference, twice angles at circumference. That is the reason, and that is the solution. So the answer is x is equal to 55 degrees. So I think now we should look at another consequence of this theorem. It's also a corollary. It's also a corollary of the main theorem. And the main theorem is angle at center twice angle at circumference. So this is also a corollary. Corollary number 5. So this corollary is saying angles in the same segment are equal. So this is what the theorem, the corollary is saying. That if O is the center of a circle, and you have this angles in the same segment. So you see O is here. So this line is still forming an angle. Another angle is formed here. So what we are saying is this angle is equal to this angle, meaning the two angles here are the same. Call this angle X, call this angle Y, call here A, call here A, B, C, and D. Let me make this O a little bit bigger. So what the theorem is saying is the result is saying is that this angle, these two angles, X is equal to Y. So observe that angle A, let me just use the variables X and Y. So this angle X is equal to angle COD. This angle COD. This angle. So COD divided by 2. So which means you are saying that 2x is equal to angle COD. Y, angle at center twice angle at circumference. Similarly, in the same way, this angle, y, 2 times y will be equal to angle COD. The same reason, this is half of this. So angle at center twice angle at circumference. That is the same reason. So what are you saying? 2y is equal to COD. 2x is equal to COD. That means 2y is equal to 2x. Dividing both sides now by 2, you have angle y is equal to angle x, or angle x is equal to angle y, meaning that the two angles are equal. So angles in the same segment are equal. That is what the corollary is saying. So now let's take some few examples, or just one example, one or two examples. Okay, example 6. Find the value of the marked or the lettered angles. Find the values of the lettered angles. A, you have a circle, so the circle is not drawn to scale. Okay, the circle is not drawn to scale. So O is the center of the circle. Good, and here is 47 degrees. Here is A. B, B part of the question. Here is E, and here is here is 85 degrees. B, C, D. And here is X. We are asked to find the value of X. Okay, the solution. Let's start with A. Directly, we can apply the theorem and just say angle in the same segment are equal. So directly A is equal to 47 degrees. Why? We have to state the reasons. These angles in the same segment. Angles in the same segment are equal, and that is the solution. So let's go to the next question. The question is saying we should find the value of x in B. Find the value of x. You cannot just go direct. Suppose you have a value here, you can say that this value is equal to x. Let me check what this means. CBX. So this angle, see, this point is x. CBX. So not this angle. This is the angle we are looking for. Here is x. Sorry about that. So here is x. And then that is the angle we want to find. Had it been you have a value here, you can say x is equal to this value, but we don't have. So meaning we should find this angle and equate it with x. So this point is, the center is x. Well, let me just write O. O is the center of the circle. So now to solve this, we need to say that the angle AOD, this angle here, is equal to 85 degrees. Why? The reason is vertically opposite angles. Vertically opposite angles are equal. So if you have two straight lines doing like this, forming an X shape, so the angle above is equal to the angle below, and the angle on the left is equal to the angle on the right. So we call them vertically opposite angles, and they are equal. So this angle is 85 degrees. So let's write 85 degrees. So, but these two angles are equal since you have OA is equals to line OD. Why? They are radii. OA is equal to OD. They are radii, each starting from the center to a point on the circumference. So they are radii, and therefore angle OAD, this angle A is equal to angle what? Is equal to angle ODA, or angle ADO. These angles are equal. Reason: base angles of isosceles triangle. So since they are equal, actually now from same triangle, A, from triangle ADO, in this triangle, you have that OAD plus ADO plus 85 degrees, because here is 85 degrees, is equal to 180 degrees. Why? You have to state the reason: sum of angles in a triangle. That is the reason. So that, but this ADO are the same, so you can say this is what? 2OAD plus 85 is equal to 180 degrees by this. So that 2OAD is equal to 180 degrees minus 85 degrees. So this is 2OA. If you subtract, you are going to have 95 degrees. Yes, you are going to have 95 degrees. So here, yeah, it's 95 degrees. So that each of them, so angle OAD is equal to angle, they are all equal, ADO, and that is equal to 95 over 2. Each of them is equal to 47 47.5 degrees. Yeah, 47.5 degrees, if I'm not mistaken. Yeah, that is 87.5 degrees. So what are we looking for? So here is meaning this angle is 47.5 degrees. 47.5 degrees. So x is also 47.5 degrees. Therefore, x is equal to 47.5 degrees. Reason, angles are in the same segment. So angles in the same segment are equal. And that is the solution of the problem. Thank you for watching our videos. Please do like, share, subscribe, and do other activities on our YouTube channel for more videos. Thank you.